Dear all, now we are going to see AlexNet. So, which is the first CNN model which is given in your syllabus module 1. So, AlexNet comes under deep CNN model. So, AlexNet is a deep convolution neural network used for image classification. The main purpose of using this AlexNet is image classification purpose. If you are giving some images for classification, suppose for example, if you are giving the combination of both dog and cat images, it will classify the images into category as dogs and then cat. So it consists of multiple convolution and fully connected layers designed to extract features and perform classification efficiently. When we are giving some images, from that images, it will extract some features, important features from that image and perform classifications accordingly. So AlexNet is a famous convolution neural network architecture. It is introduced by Alex Krishkai, Izia Sutskever, and Geoffrey Hinton in 2012. It achieved a major breakthrough in image classification and helped to establish deep learning as a dominant approach in computer vision. So its features are: it uses ReLU activation, rectified linear unit activation, enables faster training and better gradient flow. So dropout also we are going to use this in AlexNet CNN model. So what is the purpose of dropout? Dropout means it reduces overfitting in fully connected layers. Data augmentation also main factor in this AlexNet. So what is meant by data augmentation means it's creating new training images from existing images by applying small changes or transformations. So the main purpose is to increase the variety of training data and help the CNN generalize better to new unseen images. Helps in improving model generalization on image data. So this is AlexNet architecture. This AlexNet has 8 learnable layers. That means training layers. So in that 8 learnable layers, 5 comes under convolution layers and 3 comes under fully connected layers. So the overall flow of AlexNet is from the input image. The image is passed to convolution layer 1. After convolution layer 1, pooling layer is applied. It is going to reduce the dimension of this image. And after that, the input is passed to convolution layer 2 and then the pooling layer 2. Then it is passed to convolution layer 3, then convolution layer 4, convolution layer 5, at last pooling layer 5. So the output of this pooling layer 5 is passed to fully connected layer 6, fully connected layer 7 and fully connected layer 8. After the final outcome is passed to the output, which means the classification is done by using some activation function like softmax. So the 5 convolution layers with max pooling after the first, second, and fifth layers overlapping max pooling. That means 3 cross 3 filter with stride 2 we are going to use to improve the performance of the particular feature. So 2 fully connected layers with the dropout for regularization technique. Softmax layer for final classification output, which means we are going to use softmax activation function for the final classification output for the particular image. So this is the overall architecture of the AlexNet. We are going to give some input image, so which is passed to convolution layer 1 and then max pooling will be taking place after convolution layer 1. Then it is passed to convolution layer 2, then max pooling 2 layer is placed in between the convolution layer 2 and convolution layer 3. After that, continuously 3 convolution layers are placed by which the output of the max pooling 2 will be passed to the convolution layer 3 and then the convolution layer 4 and then the convolution layer 5. So after this outcome is passed to max pooling 3. So this max pooling layer output is passed to fully connected layer 1 and then to fully connected layer 2. After that, finally in output layer, softmax activation function is used to classify the particular input image. So this is a parameters which is used in different layers. Whenever we are taking some input, operation is an image. So the main parameters here is the image is converted to pixels. That means height, width, and then the number of channels. The first parameter is a height, 227 into width, 227 into number of channels. That means we are giving some color image, means there will be 3 channels. So it is 3. So then it passes to convolution layer 1. So in convolution layer 1, we are going to apply ReLU activation function to extract the features in the input image. So we are going to use 96 filters, which is the size of 11 cross 11 matrix with stride 4. So again, after that is passed to pooling layer 1, we are going to take place a max pooling. So 3 cross 3 with this stride 2 we are going to take. In that matrix, it will the max pooling will extract the maximum data from that matrix. So then it is passed to convolution layer 2. Again, we are going to use with convolution and rectify linear unit activation. Here we are going to use 256 filters with 5 cross 5. So then it is passed to pooling layer 2, then it's passed to convolution layer 3, 4, 5. After pooling layer 5, again we are going to apply max pooling with a stride of 3 cross 3, stride 2. So then it comes under fully connected layer. In fully connected layer 6, we are going to apply again relay activation with 4096 neurons for future extraction purpose. In future, in fully connected layer 7 also, we are going to apply relay activation for 4096 neurons for future extraction of the particular image. Again, it is passed to fully connected layer 8, which consists of 1000 neurons to classify the record images pixels. So again, in output, we are going to apply softmax activation, by which it produces 1000 classes of the record input image. So in input layer, AlexNet was designed for ImageNet classification. The original architecture uses an image of approximately 227 into 227 where 227 is the image height, and again the 227 is the image width, and the 3 is a number of channels. So the input contains range of 227 into 227 into 3. That means 1,54,587 pixel values we are going to pass in the input image. So next, first convolution layer, we are going to use 96 filters of size 7, 11 into 11 size with a stride s is equal to 4. The convolution operates to extract features such as edges, lines, corners, color patterns, and simple textures. The output size can be calculated as output is equal to n minus f plus 2p by s plus 1. For example, if we are giving some values for n, f and p, therefore we are going to apply these values in the particular formula to get the output. So now we get 55 into 55 into 96. So the input image is compressed, input image pixels is compressed and gives a value of 55 into 55 into 96. So ReLU activation purpose is it will take the maximum of 0 comma x values. Suppose our input is 5, means this ReLU will automatically convert the negative value to 0. If you are giving 0, it will display 0. If you are giving some positive value, then again the positive value is replied in the output. So why ReLU we are going to use in this means it introduces non-linearity, computationally simple, helps reduce the vanishing gradient problem, trains faster than sigmoid tangents in deep networks. AlexNet was particularly important in popularizing ReLU in CNNs. So here, what is the purpose of max pooling here? To reduce the spatial dimension. Suppose if you are taking some matrix 2 cross 2, max pooling gives the value of 5, which retains the highest value in the given matrix. So purpose of max pooling to reduces the future map size, reduces computation, provides some translation invariance, retains strong features. So convolution layer 2 to 5, the deep convolution layer learn increasingly complex features. Early layers, it will take edges, lines and colors. Middle layer, texture, shape and patterns. Deeper layers, object parts into complex structures. So for example, in convolution layer, we are going to pass some edges, means convolution 2 will take textures, convolution 3 will take the shapes of the particular image, convolution 4 will take the ear, eyes, legs, something like that. Convolution by 5 will take dog-like object features. So fully connected layer, after the convolution and pooling layers, the future maps are flattened. The flattened representation is passed to 4096 neurons present in the fully connected layers, followed by relay activation. Again, it is passed to fully connected layer 7 with the same 4096 neurons, followed by relay activation. So these layers combine the extracted features to perform classification. So final fully connected layer, the final layer FC8 contains 1000 neurons because the original access was trained on 1000 imaginary classes. For example, dog, cat, car, cars, other. So the probabilities are generated using the softmax activation function, by which the formula is given by P of I is equal to y is equal to e power zeta divided by summation j is equal to 1 to k e power zj. The classes with the highest probability become the prediction of the output. So important features of AlexNet, here we are going to use relay activation. It significantly improved training speed by giving the formula f of x is equal to max of 0 comma x. So we are going to introduce dropout in the AlexNet is used to used in the fully connected layers to reduce the overfitting. Typically, dropout probability be 0.5. So during training, some neurons are randomly deactivated. So data augmentation is a very important concept which is applied in AlexNet. It is used to cropping, horizontal flipping, color changes. This increase the effective diversity of training data. So local response normalization, the original AlexNet also used local response normalization. However, modern CNN architectures generally prefer batch normalization or other normalization methods. So why AlexNet was important means before AlexNet, traditional computer vision often relied heavily on manually designed features. AlexNet demonstrated that a deep CNN could automatically learn useful image features directly from raw pixels. The major idea was raw image is converted to automatically learned features and then it comes under classification. So this becomes a foundation for later architectures such as AlexNet, VGG, GoogleNet, ResNet, EfficientNet, Vision Transformers. So thank you.